Hi guys, hope you're doing well. Um, this week's physics is low-key hard, but I'm gonna try my best to explain it. Okay, so here they're telling you that this is a triangle and it can rotate about a vertex x. That means that this, A. That means that this A is its pivot, so it can rotate about A, so that just means it's its pivot. So any force acting on the pivot is obviously, it will have no effect on it, so it will be zero. So all, like directly F1, you just cancel it out, and then F4 is basically just pulling the triangle, like there's no rotation. I can't really explain it while speaking, like you have to try it physically, but just imagine you have a book and you're just pulling it, you know what I mean? Yeah. So it's all of them except for F1 and F4. This one I'm also gonna try my best to explain, but they want the greatest force. Basically, I'm just gonna say like this: greatest force, try and take it with no angle, basically, just straight-forward. 5 is obviously not gonna happen because it's basically just putting it. But opposite direction, 1 over here, imagine you're uh, like imagine you're holding that. Would you pull it to the side? But that would not have the maximum effort unless you put it directly down and hard, you know what I mean? Okay, for this one they want the force on B. Don't tell me B is a pivot and I don't know what just because it has a ball on it. No. Okay, they're telling you the axis of rotation is at A, so that means A is the pivot. B is not a pivot, it's just a point, okay? So it's not zero. If the force was acting on A, then it would be zero, but it's acting on B and B is not a pivot. They didn't tell you the axis of rotation is at B. So what's the formula? The formula is M, they want the moment. M is equal to F times the perpendicular distance. So this is your force. You're gonna just continue the line until you reach it's facing the other side, and then you make another line. So this is its perpendicular distance. It's not the line where the force is acting, it's the line you kind of make a triangle with it. So then it's just 10 times 1, which is equal to 10. For this one, basically same thing. They're telling you this is the force and they want it acting on the body, which is this brown thing. Okay, so they already continued the line for you, and then you're gonna make a perpendicular whatever. So this is your perpendicular line. It's perpendicular with the 0.2 distance. So M is equal to F times the perpendicular. So it's 20 times 0.2, which is equal to 4. And it's rotating. This, again, you have to imagine it. If you're pulling it like this, then it's gonna go like that. Try pulling your book from the bottom. Put your book horizontally, okay? And then try pulling it from the bottom corner. It's gonna rotate like this. Imagine this is your book. Try pulling it from here, it's gonna rotate like that. So that's why it's counterclockwise, which means it's positive. It's easy, but it's just the directions that's gonna it's gonna confuse you a little bit. But look, they want you to get the net moment about O. So they want you to find all the forces acting on O and add them together. But don't forget about the positive or negative direction, so clockwise or counterclockwise. This means counterclockwise and this means clockwise, by the way, okay? So F1 on O is the pivot, so it's 0. F2 on O, you're gonna continue the line and then you're gonna find its perpendicular distance, it's 2. So 20 times 2 is 40. It's counterclockwise. Why? Because if you pull it, again with your book, imagine this is your book. Put it like this. How is it gonna, it's gonna rotate, like, okay, yeah. If you pull your book like that, it's gonna rotate backwards, so counterclockwise. So that's why it's positive. Don't forget the positive and the negative. And then for F3, when it's like no angle, yeah, you just add the distance directly, because like this is the perpendicular, you know. So 15 times 5, and it's clockwise, because if you pull your book like this, تطلع يعني هيك. So, you know, you just have to like visualize it, or like do it yourself, basically. Is the same thing. If you take your book and put it like this, okay? Like, okay, but keep like something heavy here, like your finger, let's say. Pull it up like that. It's gonna rotate هيك, like that, okay? That means it's out of the plane, which means counterclockwise, which means positive sense. And here they want the magnitude of F on vertex A. So you're gonna do your perpendicular line. By the way, like, it's never the line that you, like, it's never the distance that you extend the force from. So it's never the line of the force, it's the line perpendicular to it. So when I extend the force, I don't mean this is the distance. This is not the distance. It's the line perpendicular to the force. Okay, so it's this one. It has to be in meters, so divide by 100, and then just multiply them, you get 12. Okay, they gave you all the forces at the top here. So F1 on A is obviously 0, because A is the pivot, so 0. And F2 on A is, we did the perpendicular line, so we found that the distance is 6, and it's negative because, again, if you use your book and you pull it like this, it's gonna turn like that, okay? It's basically like opposite senses. Like, if you go like that, I generally don't know how to explain it, just like do it however you like to. So it's negative 120, and then F3, again, if you take your book and go like that, it's gonna rotate like this. So yeah, and it's, the distance is 12y because you add these from point A to point C, you add them. So it's positive 72, and then the net, you just add them all. So negative 120 plus 72 plus 0 is negative 48, so that means it's clockwise. Okay, this one is like the question with the wrench and the hand. I told you that the largest turning effect would like be the one that's most straight, not angled, okay? Don't tell me what's the difference between F2 and F4. Imagine you have a wheel, and when you're steering a wheel and your hand is here, do you just like pull your hand to the right to turn your wheel? No, you pull it either down or up, okay? And then what's the difference between F3 and F4? When your hand is on top of the wheel, yeah, do you pull it up or do you pull it down? Neither. You pull it to the right, which makes it go down, or you pull it to the left, which makes it go down like that. Okay, so it depends where you're placing it, okay? Like, just visualize, okay? That's the most thing that's gonna help you in this exam. So it's F2, and then no effect is F4, because you're basically just pulling the wheel or whatever it is. I tell you, they want the magnitude. Yeah, they don't want the direction. They don't want counterclockwise or clockwise. So these are 0 because they're acting on the pivot. Okay. F3 about A. So F3 is here. About A, you do your perpendicular line. This is your distance. F4 about A. F4 about A. You just take this distance, so it's 7. F1 about A. Sorry, no, F1 about B. F1, let me erase this. F1 continue its like thing. It's not 3, it's the line you like that's perpendicular to your force, which is this one. They don't give it to you. What you do is the Pythagorean theorem. So you get HB is 4, so it's just 15 times 4. F2 about B is just 20 times the distance between them, which is 5. And the last one is F4 about B. Also the distance between B and C is 2, so 10 times 2. Okay, this one, they want the net moment of the forces acting on point A. So F1 on A, you're just gonna go down, and then the perpendicular distance would be half of 12, which is 6. Keep it in centimeters because they told you Newton per centimeter. So it's just 8 times 6, which is 48. F2, if you continue the line, it's acting on A, so 0. F3 on A, again, continue the line. Do it based on what, like, they already lined it for you, look. So don't go here and then here. Don't do that. Just continue. Also, that's not where the force even is. Okay, whatever. So the force is 4, and then the distance is 5. So it's 20, and it's clockwise. So negative 20, and then add them, and you're gonna get 28.